Hello everyone, writing on first class solution. Today we have a unique problem which we want to provide solution to. This is a matrix A. We want us to calculate the inverse of this matrix. And looking at this matrix, we observe that it has an unknown. This is a 3 by 3 matrix in the sense that it has 3 rows and 3 columns. They want us to calculate the inverse of this matrix. And to calculate inverse of a matrix is not as difficult as it sounds. First of all, you get the determinant of that matrix. You get the cofactors of the matrix. Then in those cofactors of the matrix, you transpose, and when you transpose to get the adjoint, you now divide each of those adjoints by the what? By the determinant of the matrix. Then it will give you the inverse of that matrix. So in this case, this is not just a 3 by 3 matrix. The 3 by 3 matrix that contains an unknown. And in calculating for the inverse of this matrix, this unknown needs to be taken well care of. But it told us that we should find this unknown, this x, if the inverse, this is the denotation for an inverse. They say if the inverse of this matrix A is this, then we should calculate for this unknown. So we have a unique problem at hand in the sense that we will calculate for the inverse and get the unknown, which will replace this S to get the complete value of this matrix A. So let's get started. First of all, calculate the determinant of this matrix. Remember I told you the step. First of all, get the determinant. To get the determinant of this matrix, determinant of matrix A is equal to, in getting determinant, the first row is very, very much important. And in this first row, we have our plus, minus, and plus here, which we get the factor here as 1 into what? Into, when you cover here and cover here, we have minus 3 and minus 2 into minus 1 and x. Minus 1 into, cover here and cover, see the first column, cover, see the first row, cover the second column. This time around, you'll be left with minus 2, 1, and x. So you have minus 2, 1, and x. Lastly, we have plus 1 into what? Into cover here and here. We have minus 2, 3, 1, and minus 1. So minus 2, 3, 1, and minus 1. So you're getting the determinant. You say this times this minus this times this. As the product of this and this minus the product of this and this multiplied by the coefficient 1 here. 2 minus 3 times 3 will give you minus 3x. Minus 2 times minus 1 will give you plus 2. So because of there's an original minus here, you have minus what? 2 into minus 1. Minus 2 times x will give you minus 2x. 1 times minus 2, you have minus 2. Minus original minus that we're supposed to have here, and the minus will give us what? Plus 2 into plus 1 into minus 2 times minus 1 will give us what? Plus 2. So we have our 2 minus 3 times 1 will give you minus 3. So with this minus, it becomes plus 3. So we have our determinant to be minus 3 minus 2. We have minus 3x minus 2. That is minus 3x minus 2. Multiplied by 1 will still give you the same thing. 1 multiplied by this, we have what? Plus 2x. Minus 1 times this, we have minus 2. Plus 1 times 2, we have, well, let's just sum this up as 5. 1 times 5 will give us what? Plus 5. Then we collect our like times as minus 3x plus 2x will give us what? Give us minus x. Minus 2 plus 5. Minus 2 will give you minus 4 plus 5. Minus 4 plus 5 will give you what? 1. That is plus 1. So our determinant here is what? X minus x plus 1. We'll just simply have it as, have your determinant as what? 1 minus what? X. If this is our determinant, remember I told us that in getting the inverse of a matrix, we get the determinant, we get the cofactors, and in that cofactors, we transpose. When we transpose, then we now divide the values, the element of the transpose matrix by the what? By the determinant of the original matrix to get the inverse. So it means that this our determinant will be a useful tool for us. So let us get it here and save it for future reference. 1 minus what? Minus x. So our determinant is 1 minus x. Let's clean this for want of space. The next step is to get our cofactor, followed by the adjunct, then transpose, then multiply transpose by 1 over the determinant. That means to say to divide the transpose by what? By the determinant. So let us continue. We'll follow this step and we will get it right. In this matrix A, to get the cofactor, you have to take note of the signs. We have plus, minus, plus here, minus, plus, minus, plus, minus, plus. So we've taken note of these signs. Now our next step is to get the cofactor. How do we do in terms of getting the full cofactor? We just have to cover this first column and this first row to get the elements that will be in there. We have this element. If you cover here and here, we have -3, -2. Then the next one will be, we've covered here and here. The next one will be -1 and x. -1 and x is one of the cofactors. Then the next one will be covering the, remember you started with the first column. Then the next one will be second column. Still cover the first row. If you cover this first row and this second column next, we have -2, 1 and x. So we have -2, 1 and x. We're going further. The next one will be covering still the first row and the last column. We have -2, -3, 1 and -1. -2, -3, 1 and -1. Then the next one, we are done with the row. The next will be, we're done with the first row, not all of the row. We're done with the first row. The next one will be the next row, that is the second row. We have to cover the second row and come with the first column. So if we cover this second row and this first column, what do we have? We have this and this, this and this. So that means to say we have 1, 1, -1, and what? X. We are trying to build our cofactors. Then the next will be what we have here, what we have here, what we have here, what we have here, 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 and here. So let's fill it up together. Remember, we'll cover this second row and this first column. So we'll cover the second row and the second column. So if we cover here and cover here, we'll have 1, 1, 1, x. So we have 1, 1, 1, x. Going forward, we have still on the second row and the last column. We cover here and this last column. We have 1, 1, 1, -1. So we have 1, 1, 1, -1. Okay. Come back to the first column and the last row. If you cover this first column and this last row, you have 1, 1, -3, -2. 1, 1, -3, -2. So these are our what? Our cofactors. Now the elements in the cofactors, after you've done the determinant, is what you get as your what? As your adjunct. So what's our adjunct? Our adjunct will now be the determinant of this cofactor put in a matrix will now become, this implies -3 times x, get the determinant of all of them, -3 times x minus -2 times -1. That means to say the product of this minus the product of this. So we have -3 times x will give us -3x. Then -2 times -1 will give us what? Will give us +2. So -3x -2, you have -3x -2. Okay. The next one, -2x here. Then this will give us -2. -2x -2 will give us -2x plus 2. Then -2 times minus 1 will give us plus 2. This will give us minus 3. Then we have 2 minus minus 3. We have 2 plus 3. We have 5 here. Okay. Let's move on. The same with this. 1 times this will give us x. This will give us minus 1. So x minus minus 1 will give us x plus what? Plus 1. Here, 1 times x will give us x. 1 times 1 will give us 1. X minus 1 will give us x minus what? 1. So we have here 1 times minus 1 will give us minus 1. This will give us 1. So minus 1 minus 1 will give us what? Minus 2. Here, 1 times minus 2 will give us minus 2. Then 1 times minus 3 will give us what? Minus 3. Minus 2 minus minus 3 will give us minus 2 plus 3. So minus 2 plus 3 is what? 1. That means you are owing 2 items and you are having 3. Minus 2 plus 3. So when you pay the 2 you are owing, you should be left with what? 1. Here also, 1 times minus 2 will give us minus 2. Minus 2 times 1 will still give us minus 2. So minus 2 minus minus 2. Minus 2 minus minus 2. You have minus 2 plus 2. So minus 2 plus 2 will give us what? 0. Then the last one, 1 times minus 3 will give us minus 3. 1 times minus 2 will give us minus 2. So minus 3 minus minus 2 minus 1. So if this is the case, it means that this is our what? Our adjoint. So let us transpose this adjoint to get the transpose of this matrix. Let us transpose this adjoint. In transpose of matrix A will become, the transpose of matrix A will now become, how do we go about the transpose? Transpose is obtained when you make the row to form your column and the column to form row, in the sense that all the elements in this row will form our what? Our column, whereas all the elements in the column will form the what? The row. So let us do it together. Here in this column, in this row, we have minus 3x minus 2, minus 2x plus 2, and 5. So instead of writing it out as row here, we'll form it as a what? As a column. So we have minus 3x minus 2, minus 3x minus 2. We will not continue like this. We'll come here. Minus 2x plus 2, minus 2x plus 2. Then, instead of writing 5 here, we'll bring it down here, and 5. We'll do the same thing for this. So this is the transpose of this matrix. This is the transpose of this matrix. And in our step, after getting our transpose, we what? We divide the transpose by the what? By the determinant of this matrix A. Remember, we got our determinant to be 1 minus x. We have to divide the transpose of this matrix to get the what? The inverse of the matrix. So the inverse of that matrix, which is denoted as this, is equal to transpose, that is transpose of A over what? Determinant of what? A. So what is our transpose? This is our transpose. So let us divide the transpose by the determinant. We got, let us bring a big matrix here. We have minus 3x minus 2, minus 3x minus 2, all over what? 1 minus x. Next one, x. Let me rule here for sake of clarity. X plus 1 all over what? 1 minus x. The next one will be 1 all over what? All over 1 minus x. The next one will be minus 2x plus 2 over what? 1 minus x. Next one will be x minus 1 over 1 minus x. The next one will be 0 over what? 0 over 1 minus x. Next one is 5 over 1 minus x. Next one is minus 2 over 1 minus x. And the last one will be minus 1 into 1 minus x. Now remember, initially we had the signs. Take note of the signs. I did not bring it at first so that it will not be too complex for us. So remember our signs. We have plus, minus, plus, minus, plus, minus, plus, minus, plus. Now, if that's the case, the determinant here, the signs will affect each of the elements in this what? In this inverse they were trying to create. If that's the case, we now have inverse of matrix A to be what? Here is plus, it will not change. Here is plus, it will not change. We have, what is it that we have? We have minus 3x minus 2 all over 1 minus x. Here minus, we have, if minus is to multiply all of these, we have minus what? X minus 1 all over 1 minus x. Here being plus, it will not change. 1 over x minus 1 minus x. Here minus will affect what we have here. We have 2x minus what? 2 all over what? 1 minus x. Here plus, remember the sign, it will not change. X minus 1 all over 1 minus x. Here minus, we have still 0 all over 1 minus x. Here being plus, we have 5 will not change all over 1 minus x. Here minus, it is expected that once it's minus will multiply this to become plus. So we have 2 over 1 minus x. Here is what? Plus. It will not change. We still have our minus 1 all over 1 minus x. So this is the inverse of the matrix. Now, this is not the end of the solution, because they asked us, they told us that we should find the value of this unknown, this x, this unknown. Supposing there is no unknown in this equation, in this matrix, it would have been values all through in the elements of this inverse of matrix A. But because of we have unknown, we keep having 1 minus x, over this minus x minus 1 and the likes. So they asked us to find the value of x if the inverse is this 3 by 3 matrix. And so we should find the value of x if the inverse of this matrix is a 3 by 3 matrix. That means to say we should find the value of x if this is equal to 8. Are you getting it? If minus 3x minus 2 over 1 minus x is equal to 8, or if this is equal to 3, or if 1 over 1 minus x is equal to minus 1. So whichever element in this matrix we pick to equate what we have here, we'll get the value of x. So let us calculate to get the value of x. Let 5 over 1 minus x be equal to minus 5. You know what we did? We took these elements here to equate the third element here. So if that's the case, this element being 5 over 1 minus x should be equal to 1 minus 5, the same as this. So it now implies that we'll cross multiply. This can be written as 5 minus 5 over 1. So this multiply this and this multiply this. So minus 5 multiplying this, we have minus 5 into what? 1 minus x being equal to 5 times 1 will give us what? 5. So it implies that minus 5 times 1, we have minus 5. Minus minus will give us plus. 5 times x, we have 5x equal to what? 5. So if that's the case, just collect like 10. Take this to the other side. We have 5x being equal to minus 5 going here becomes plus 5. You have 5 plus what? 5. Implies that 5x is equal to what? 10. If 5x is equal to 10, it implies also that x is equal to what? 10 over what? 5. And x is equal to what? 2. So if that's the case, it means that we've had our x being equal to 2. In the sense that the original value of x that was supposed to be here is 2. So if you find this video very helpful, kindly like, share, and follow our page on YouTube so as you get more content like this as soon as it drops. God bless you.